Welcome to my channel Maithili SK. In this session we are going to see about superheterodyne receiver under unit 1 EC 3491 communication systems. This is our last topic in first unit. So to start with this introduction about receiver is given, and importance of RF mixing is explained, and what are the requirements of the receiver is explained, and what are the types of receiver is followed. Receiver characteristics is explained, and finally we'll explain with AM superheterodyne receiver, and the advantages, disadvantages and applications will be finally discussed. To start with introduction about receiver. So what is basically a receiver? We have seen this in the introduction class itself. Receiver is nothing but yourself. That is, it is a device that receives radio waves and converts the data into usable form. So here I am the transmitter and you are all the receiver. So whatever I am communicating through this medium is received to you. So you are all the receiver. So it receives the inputs whatever is transmitted by the transmitter side, right? So the antenna present at the beginning of the receiver station receives the modulated wave, and it is given to the demodulation process by using an envelope detector in case of AM receiver. Whereas in case of FM receiver, the FM wave which is received will be demodulated by means of using frequency discrimination method. So the methods are different, but it is the same process. To get back the original message signal, we'll be processing with the demodulation path. So receiver is denoted by means of this symbol. Whenever you draw the receiver in the block diagram, you have to draw like this. So single antenna. Here different antenna structures are used to specify different structures like dish antenna. This is a monopole antenna, and here this is a transmittering antenna, and here different sectors are specified in different structures or different data. So you could see the signal reception technique is explained here with RF mixing. So when we are considering an RF mixing, it is nothing but the expansion here is standing for radio frequency. So radio frequency signal is nothing but which is consisting of the input signal which is mixing with the signal which is to be transmitted and produces the signal reception. So the RF mixing unit develops an intermediate frequency to which any received signal is converted so as to process the signal effectively. So RF mixer is an important stage in the receiver end because it have to produce the intermediate frequency by which the channel is to be taken care. So two signals of different frequencies are taken where one signal level affects the level of the other signal to produce the received signal output. So the input signal and the resultant mixer signal output is mixed or shown here. So if this is the input signal which is taken at a particular frequency and another signal is taken at another frequency, if these two signals are mixed together, there will be an intermediate frequency which is generated and produces an output when it is given to the RF mixer stage. So let us first discuss with respect to two frequency signals. Let the first and second signal be F1 and F2. So input signals. So what will be the resultant output will be F1 plus F2, either it will be F1 minus F2. So the intermediate frequency is nothing but which is present between these two frequencies, and if these two signals are applied to the RF mixer, it produces F1 plus or minus F2. That is the same case, it produces both the half and plus. There is intermediate frequency is nothing but frequency which is produced in between. So here two signals F1 and F2 are transmitted. So F1 plus F2 can be generated or F1 minus F2 can be generated. So this is known as the intermediate frequency. Okay, so what will be the requirements of the receiver? So requirements of receiver falls in the case where it should be very much cost effective. It should not be much high, and it should receive the corresponding modulated waves properly, Otherwise, the receiver will not be able to follow what the information is given, and the receiver should be able to tune and amplify the desired station, and it should have the ability to reject the unwanted signals. So if you are hearing my voice as well as the other signal voice, so your ability to grasp what the class is being taught in this session is very, very important. So you have to tune yourself to keenly note what is taken in this class. Otherwise, if you are able to receive all sorts of noise or communication, your friend is talking to you, that is also a signal, right? So you have to listen to the received signal. What is very much important at that point is to be noted, right? So that way, that's how we can relate the receiver requirements. And demodulation has to be done to all the station signals irrespective of the carrier signal frequency. So demodulation will be done at the receiver end, and which signal frequency is not dependent on factor. It is about the carrier frequency, whatever is taken. So what are the types of receiver is? There are two types of AM receivers which are popular and are commercial. It starts with tuned radio frequency receivers, that is shortly called as TRF receivers. We are not concentrating with this because it has some drawbacks in it, which is about the linearity case. So super heterodyne receiver is a best one, and it is commercially well and good among all the types of receivers whatever we are using now. Though regenerative repeaters, whatever has come into picture today, the super heterodyne receiver is important, and it is most widely used, commercially used receiver. So this is the receiver you are going to study in your syllabus too. So what are the receiver characteristics? So the receiver characteristics is nothing but, as we have said, receiver is a part which is at the receiving end or the demodulation part. So we need to demodulate the signal, means we have to get what is the original message signal is being transmitted. So this receiver must be having a characteristics which should be able to pick more signals which is coming or present through the signals, right? So the channel has a n number of signals, but the receiver at the receiver end must be able to pick which is the actual signal to be received at the receiver end. So this is very, very important point when considered. So it should be included here, which is related with sensitivity or threshold, and selectivity, stability, fidelity, signal to noise ratio, and dynamic range. So it is all dealing with the 6 characteristics. What is sensitivity or threshold here is, it is a measure of the receiver ability to receive even the weak signals. So among the signals, whatever I have drawn, this green signal is the signal which is to be received by the receiver at the end. So even if this is a very weak signal, this receiver should be able to receive it. That is called as sensitivity. What is selectivity? So ability of the receiver to select the desired signal among various signal presents and rejects the unwanted signals. So similarly here, if all these red signals are the unwanted signals, the green signal is the only signal which is to be picked by the receiver at the receiver end. So here n number of signals are present at the channel. So though n number of signals are present at the channel, the receiver must be able to select particularly this green signal among all these signals which is present here. That is called as selectivity. And what is stability? Stability is nothing but the ability of the receiver to deliver a constant amount of output for a given period of time. So you could see here, some of the receiver will have the ability to receive the power in various states. So here the stability is nothing but it should be able to receive, or it should have the constant amount of output. So for a particular period of time, this received signal must be able to pick the signal which is present here. It is a green signal. That is the ability of the receiver to deliver a constant amount of output for a given period of time. So if this is T1 period, If this is it should be able to receive between this period. So that is called as stability. What is fidelity? It is the measure of ability of communication system to produce exact replica of the original information. Fidelity is nothing but duplicating, we can say. So if you want to duplicating, in the sense, it is not duplication actually. So from the transmitter end, it should produce the exact replica. That is what the meaning here is. So the green signal, whatever we have received in the previous part, must be the exact signal what is present here. So if I am sending a message hi here, the same signal must be received here with respect to hi. Instead, if I am sending a signal hi and if a h alone is received, that is a mistake. Or if there is an addition of a signal, that is also a mistake. So that will all results in error production or error occurrence, which will be discussed in our third unit later. So next is about the signal to noise ratio. So what is signal to noise ratio is nothing but, as I said, with respect to signal power and noise power. So what is signal power is here is whatever I am giving, or I am the information being transmitted at the transmitter end, and you will be receiving my voice or audio signal. So if you are able to receive all sorts of noise along with my original signal, someone is speaking to you, if fan is running above your head, if AC is running around you, if some students are walking next to your classrooms, so all sort of noises are present. So this noise must be much lesser than the signal level what is being transmitted. So what is the point here is, whatever be the situation, you must be able to grasp what is the original signal being transmitted, and noise must be much lesser. So though if you are able to reduce the noise at the surrounding level, example I have shown you with the switching off the fan. So if I switch off the fan, you will be able to hear all sorts of noise around your environment. So noise cannot be made to zero, but it can be reduced. So what is the point here is, here the signal condition must be much higher than the noise level. So that is called as ratio of output signal to noise power ratio. So next is nothing but super heterodyne receiver. Now comes into the picture of our original topic, super heterodyne receiver. What is a super heterodyne receiver is nothing but, it is often shortened as superhet. So what is a het is nothing but, we can say it is mixing of signals. So it is named so. So it is a type of a radio receiver that uses a frequency mixing. Right, let me take this pointer. So it is a type of mixing which is fed as an input to it. You could see here two inputs whichever is fed here will be mixed together to produce an intermediate frequency, what we have studied in the basics, that is radio RF signaling. So what it produces an intermediate frequency which will be carried along for a convenient process of reception. So it was invented by French radio engineer and the radio manufacturer Lucien Levy. And virtually all modern radio receivers uses this super heterodyne principle. It was basically introduced to overcome the drawbacks of the tuned radio frequency receivers or TRF receivers, and it uses the principle of mixing two signals, where the heterodyne means mixing two signals. Hence it is called as super heterodyne receiver. Okay, now what does the receiver section has? So it is consisting of the block diagrams, which is divided into 6 sections of RF section, frequency changer with intermediate frequency selection, demodulation part, and audio amplifier with AGC gain control. So the block diagram is shown here. So it consists of an RF amplifier section with the mixer and an IF amplifier. You could see IF section and the deduction or demodulation part, and it has the audio amplifier and an AGC or automatic gain control, which is to be noted here, right? So the receiving antenna, it receives the, as we have mentioned, it is noted by the antenna structure or antenna symbol. They received a input from the channel. Through the channel, the message signal or a modulated signal is taken as an input here. to the RF amplifier, that is the radio frequency amplifier, to the mixer through this local oscillator. This local oscillator is to generate a carrier signal. So we'll see one by one what happens in the RF section. So as I have earlier mentioned, it is called as the radio frequency section. So in the figure, the receiving antenna intercepts the radio signal and feeds to the RF amplifier. This RF amplifier selects the desired signal frequency and amplifies its voltage. The RF amplifier is a small signal voltage amplifier which is operating in the range of radio frequency. This amplifier is tuned to the desired signal frequency by means of capacitive tuning. And the radio frequency stage of a receiver provides initial tuning to remove the undesired image signaling. So after suitable amplification of the radio frequency signal, it is fed to the mixer. That is the next part. After all these RF amplification is done, it is passed. The signal is passed to the mixer. So what does this mixer section has? The mixer section is consisting of two. That is the local oscillator and the mixer. So the mixer consists of a nonlinear device like a transistor, and one input is fed from the RF amplifier output and another input is taken from the local oscillator. Now we'll see what is local oscillator. This local oscillator is nothing but a oscillator which generates a frequency higher than the incoming signal frequency by a value equal to that of an intermediate frequency. Simply it is nothing but a carrier frequency which is to be generated, and both the local oscillator and the incoming signal enters this mixer which forms an intermediate frequency in the mixer stage. So it provides after in this mixer stage, when these two local oscillator and the RF mixer input is fed, it produces the sum and difference frequencies, as we have said in terms of introduction itself. It produces an intermediate frequency which is having a value of FIF. That is an intermediate frequency, means it has input plus or minus F2. So it has a two frequency range, F1 plus F2 as well as F1 minus F2. So it can be denoted as F1 plus or minus F2. So sometimes this can be given in equation format of representation, where intermediate frequency IF is nothing but the radio frequency minus the local oscillator frequency. So for problematic case, if they are giving if the radio frequency is this much and the local oscillator frequency is this much, find out the intermediate frequency, means you just merely substitute the radio frequency given and subtract the local oscillator frequency. You will be calculating the intermediate frequency in terms of hertz. So this can be asked in problem. So please note down these two equations. So the difference component, which is called as intermediate frequency or IF frequency, is always a constant and will be equal to 455 kilohertz. So it is maintained for a superheterodyne receiver in terms of 455 kilohertz. Now coming to the IF amplifier section. This is the IF section, simply it can be known as. So the IF signal, which is fed to an IF amplifier with two amplifier stages, and this provides enough signal amplification so that the signal is properly detected, and the amplified IF signal is fed to a linear diode detector which demodulates the received AM signal. So after this mixer part, it is fed to the IF amplifier section. So IF amplifier section, which has an amplification factor which amplifies the intermediate frequency, and unwanted signals will be eliminated through this IF filter, which is not shown there but it is present. So intermediate filter IF filter is nothing but intermediate frequency filter, which is a band pass filter which passes only the desired frequency and eliminates all the unwanted frequency components presented. So this is the advantage of IF filter, which allows only the IF frequency, which will improve our signal condition. So signal will be much better when we are using this case. Next is then about the AM deduction or a demodulation part. So the received AM wave is now demodulated using the demodulator. So this demodulator section uses an envelope detector, which is using a nonlinear device like a diode, to receive the modulating signal and produces a modulating. There is demodulated to converted to the modulation part. So the audio next the signal which is being recovered is passed through the audio amplifier or a power amplifier. The demodulated signal will be given to this power amplifier, which is amplified to detect the audio signals. So if it is an audio or a message signal, this will be detected. If it is an audio signal, that is passed through necessary speakers, and the speaker will convert this audio current into sound energy, and the processed signal is strengthened to be effective, and this signal is passed to the loudspeaker to get the original audio signal. So the important point you have to remember here is about the image frequency case. The super heterodyne receiver, which is developing an IF frequency, when the input frequency is greater than or less than the local oscillator frequency. So you could see here the two case. Let me take this. Yeah. So you could see here it produces an intermediate frequency case when it is fed. Yeah. Super heterodyne receiver. With respect to here only it produces mixing frequency or IF frequency. So here this is called as the local oscillator frequency, and this is your input RF frequency. So this two cases here with the inputs will be with respect to two case in the mixer, that is F local oscillator plus F input. This is the F input is nothing but F RF frequency. So this produces two IF signals at the mixer output, which is nothing but F L, that is RF, F input plus or minus F local oscillator frequency. So here this mixer is not able, if there is a, it is producing IF signals at the mixer output, which is resulting in a simultaneous reception of two signals, which is differing in the frequency twice that of the intermediate frequency case. Sometimes this mixer is not able to distinguish between this desired frequency, what is to be obtained, and there will be a frequency which is called as an image frequency, which is nothing but a replica or a image of the same. So this image frequency term is given as Fs dash, that is a input frequency case. Fs dash, if it is denoted by Fs dash, it can be given as Fs plus 2, it is nothing but Fs plus twice that of the intermediate frequency, So this is how you could calculate the image frequency calculation. So this is also an important equation which is to be denoted or noted for a problem case in case of super heterodyne receiver case. So hence you might have understood what is the operation of this super heterodyne receiver. It is just the process of mixing two signals. Mixing of two signals result in intermediate frequency which is having plus or minus. So sometimes if there is a, instead of selecting the desired frequency, if there is an image frequency case, this can be represented by this equation. Right. Now coming to the application part or advantages of super heterodyne receiver, it has an excellent selectivity and it has a better image rejection quality. That is called, that's why I explained about the image frequency now. So this image frequency can be rejected by the means of this super heterodyne receiver, and it has an improved sensitivity, and it is better filtering characteristic by frequency conversion, and it is adjustable bandwidth. It has a low signal drift, and it has advanced signal processing, and multiple tuning facility is available, and frequency modulation capability is available, and it is a well established design. Until now it is being in market. And what are the drawbacks of super heterodyne receiver is its complexity is much higher, because it has to be go with AGC or a automatic gain control concept, and high cost. Image frequency issues occurs if there is no proper selection, So proper selection is must to ensure or avoid this image frequency concepts. And mixing of products is much important. And aligning and calibration of this mixing of signals is very important. Front end overloading is a drawback here, and power consumption is also high here. And what are the applications here? It includes more broad and vast applications, including all type of communications happening in our day-to-day life, in radio broadcasting, AM, FMs, etc., public safety communications like walkie-talkies, aviation communication, marine communication, hams radio, that is amateur radios, which can be set in a particular local area, that is called as hams radio, and a shortwave listening, emergency broadcast reception. So in the case of emergency, where all sorts of communication are cut, this kind of super heterodyne receiver will be able to communicate with the other globally, or outreach the other persons. And wireless communication research, it has a wide applications and industrial applications, education and training purpose, space explorations, wireless sensor networks and telemetry. So emergency broadcast reception example like tsunami, whenever tsunami occurs or environmental calamity occurs, this super heterodyne receiver plays a major role. These are few super heterodyne receivers which has been started and identified by the by some people. That is, it is a 5-tube super heterodyne receiver which was manufactured by Toshiba in the year 1955, and this is the super heterodyne transistor radio circuit introduced in the year 1975. So, what is the basic takeaway of today's topic is you have studied about the basic typical single conversion super heterodyne receiver, which here this is well explained in the Wikipedia. So, I have referred this Wikipedia to show you the difference when this is a single conversion process. What you have studied is now a single conversion process, where this is divided into three cases. The red part, this is your red, and this is your green, and this is your blue. So that's what they have explained here. The red part are those handle incoming radio frequency signal, that is about the RF part, and blue parts operates at the modulation of a frequency, and the dotted lines indicates local oscillator RF filter which is to be tuned. So here finally the output is given by the modulation part, and the green part is nothing but the intermediate frequency part. So this can also be taken into multi-tones or multiple types of multi-tones receiver signals. So one stage can be repeated here with respect to this mixer till this amplifier. So two stage can be involved here, or n number of stages can be involved here to overcome obstacles and to avoid the image uh, frequencies which is happening in the single conversion process. So to overcome image responses, some receivers uses this multiple successive frequencies conversion, and multiple high intermediate frequencies of different signals are considered here. And this frequency conversions which involves more than one IFs is called as dual conversion super heterodyne, and one with three IFs is called as triple conversion super heterodyne receiver. So this is the waveform you could see about the operation of the super heterodyne receiver, where these two signals are being considered with respect to RF filter. If it is the filtered output, when it is passed through the mixer input, you could see here it produces two. This is overlapped with this and produces the mixed output in terms of with respect to one frequency, which is an intermediate frequency among this common center frequency, and finally the filtered output will be a message signal which is being transmitted, that is a modulated output. So if this is again the waveform showing the mixer input without RF filter. So if there is no filter, you could see here there will be overlapping of image frequencies, whatever is happening. So in order to avoid that only, we go for this multiple entry path. Hope you have understood about superheterodyne receiver operations and receiver characteristics. This is a very important 13 to 15 mark question as far as university examination is considered. I hope you understood the topic. Our next topic will be starting with our second unit. Thanks for watching.